So hello, hello everyone, and we are Group 6, and our topic is Indoor Air Quality Monitoring System, and I'm Liu Xiaoheng Irvin. So let me start off by briefly introducing our topic and the reason why we choose this topic. So firstly, the air pollution problem is quite severe in Hong Kong, and for recently, because of the emission of tear gases, and it may seriously affect the health of the Hong Kong people. And allergy is one of the most common disease for the Hong Kong people, and it may even kill them in some extreme cases. And besides, the public awareness of the air pollution problem is not enough for the Hong Kong people, especially for the indoor environment. One of the examples is that the woman may stay in the shop for a long time to choosing and purchase the outfits. So if the indoor air quality conditions is poor in the shop and they stay for a long time, it may seriously affect their health. As a result, we would like to design an indoor air quality monitoring system to track the air quality and the temperature data. And we would like to improve the working environment for the employees as they may work in a company for a long time every day, and we would also like to provide a safer place for the customers to consume in the shop without any worries. So next I would like to talk about the hardware design of our system, and on the right side is about the circuit of our design. And the hardware components that we use is a Arduino board, the LCD display panel, the gas sensor, the temperature sensor, the variable resistor, some resistors, and the buzzer and the LED. So then I will talk about the simulation, about the circuit field. And after we start the simulation, and the LCD panel will display welcome to the air quality monitoring system. And after some time, the data will start being collected. And as we can see in the left picture, is the air quality data and the temperature data collected, and they will then displayed in the LCD. And the right picture is about the corresponding states which will be displayed after the data display will be the state. So next, let me talk about the function of the buzzer and LED, and we would like to use them as an alarm to warn the customers and the company side to and the air quality condition is poor, it's very poor, and or the temperature is either too hot or too cold. So for example, on the left picture, we show that the air quality value is 660. As we set the system when the air quality value is higher than 500, and the corresponding state is very poor air, which shown in the right picture. And also for the temperature, if the temperature value is higher than 34 degrees Celsius, which the left picture shown is 66.7 degrees Celsius, the corresponding state is too hot, and the alarm will be on. You can see in the picture. And for the simulation in the serial view, the air quality data and the temperature data will also be displayed after they are collected, and their corresponding conditions will also be displayed, which these value and conditions are identical to the LCD display shown in the LCD display. Yes. And next, I would like to pass to my teammate to talk about our software design.
I'm Chen Xiaofeng, responsible for the software design of our project. Now I'm going to introduce you our software design and the progress. The software design of our project could be divided into two parts. One is the programming on the Arduino, and the other is an app for the customer to view the air quality information online. First, For the Arduino programming, we want to program the Arduino board so that it could coordinate, control, and communicate with the peripheral components. Thus, every component could functionate properly. How do the Arduino read the data from the sensor? How to display the result on the LCD screen? How to trigger the LED and the buzzer according to different situations? How to transmit the data to the local computer through a Wi-Fi module? All of the above functions could be accomplished by the programming. For the data collection, it is about how do we read the data from the sensor. The Arduino would get the data by the analog read function, which gives the analog voltage according to different voltage outputted by the sensor. Then we have to transform the voltage into meaningful information. For example, for the temperature sensor, we could get the temperature in Celsius by the following equation. We multiply the voltage by 5 divided by 1024 and then minus 0.5 divided by 0.01. However, it is not the case for the gas sensor, since the gas sensor measures the concentration of different air particles but only gives one output voltage. It is hard to tell the exact concentration of each air particles, but it still gives us the relative index of the air quality. The higher voltage, the more polluted air. The system would keep reading the sensor and updating the data by loop. For the display on LCD screen, we want to show the measured data on it and keep it updated. We would use the library liquidcrystal.h which could works for all LCD displays that are compatible with the Hitachi HD447X0 driver, which could be recognized by its 16 pins interface. The library provides many functions such as begin, clear, set cursor, display, print, etc., which could help us to utilize the LCD screen. At the beginning, which means the setup of the Arduino, we must call the begin function in order to initialize the LCD, and the print function allows us to show the text on the screen, while the clear function could make the screen clear. Again, we want to keep it updated, so we put all functions inside a loop. For the LED and the buzzer, it is used as an alarm. The Arduino will keep tracking the recorded value. If the value exceeds the safety level, then the Arduino will send a digital high voltage to trigger the LED and the buzzer to alert the employee. The alarm will be reset if the value returns normal, or it could be turned off by the management cast. To build the app, we could use the online app building tool called AppSheet. It is coding-free, which means we could build the app without any programming works. And it supports the connection to online database, therefore we could extract the data from our online database directly. And it is easy to get started. But there are some limitations under the payment-free version. For example, we cannot publish this app and the app could not send notification. For the interface for customer, it is in dark mode and it would display free information for each branch as simple as possible. And we have added the icon for the recognition. For example, the location pin represents the address of the branch and the meter icon represents the measured air quality. And the user could click on the branch for more information. All the records are sorted by the air quality in the descending order. If the user wants to see more information about that branch, they could click on the branch, and then all information related to that branch will comes out. For example, the manager of that branch, the phone number, and the temperature. There are other functions, such as searching function. The user could search a branch by the branch number or the address and the menu list. In the menu list, we could see our app names and the icon and the about, feedback, and share function.
So hello, this is Liu Hong Irvin once again, and I would like to talk about our mobile applications, which is the interface for the company owner's point of view. And for this interface, we want to provide the detailed data in the form of the graph presentation and also in the table format. And for this page, the image shown is the graph presentation. For example, the name is a company A, and we can see the graph present, which is in the the company owners can see the trend. Can see the air quality data for the time, for the business hour they are operating. For example, the company A is working from 1 p.m. to 12 p.m. and they can check the data, the overall data, and for our system, let the data is if the data is less than 400, which is the fresh air conditions, and obviously for the company A, most of the time they are under the fresh air conditions, and between 400 and 500 is a poor condition, which larger than 500 is a very poor condition as well. So this is a detailed data in the table form. Which the company owners can click in each column to view the time data, the air quality data, and the temperature data as well, which is detailedly shown in this interface. And the users, as a company users, can also modify the data, delete the data, or add the new data as well. And next, I would like to talk about also we have the function of the F5s, and the company owners can click on the F5s and see, and they can view the conditions and the F5s, and you click on the branch, the details will be the conditions. For example, this company A is as their air quality value is generally lower than 400, so it is a good level. So the advice is just telling the company owner to maintain the current conditions, and as well for the temperature value as they are operating in a normal temperature. So the advice is to maintain the temperature. So this advice depends on the overall air quality data and the temperature data. So if the temperature data or the air quality data is maybe in a poor conditions, the advice will be different, obviously. So for the next, I would like to talk about the menu view. So the company owners can switch between the company. So actually at first we would like to add the login functions for each company. So for that company owner, they can only view their own company's data. But unfortunately, the app sheet doesn't provide this function for the free version, so we can't add this function. So and also the user can provide us the useful feedback, and the feedback will be sent to our email. So the bottom image shows the feedback format, and after submitting, the feedback will send to our email. And yeah, this is the end of my part, and I would like to pass to my teammates to talk about the web server.
Hello, I'm Wang Dachi, serial number 54849672, and I will respond for the web server part of this presentation. About the web server part, to make this web server, we need certain components to handle it. First is the XAMPP program. It will provide a MySQL database system. We will use it to create our own database and the table in our own computer. It is a local database system now, but we will, or maybe we can make it make a online database system after. And next, the ESP8266 Wi-Fi module. It is its main hardware component to connect the Arduino and the database system. When the data is sent into the Arduino, it will go through this Wi-Fi module and send to the server, just the database, just the graph on the right down corner. And next, the PHP code. It accepts the data transfer between the database system and the Wi-Fi module, and it is the main coding part we need to handle this web server. And finally, the Arduino ID coding. It is used to control the Arduino for us receiving or sending something. And about the database, how to create, and here is there is some pictures show how we will create this database. First, you will see the XAMPP control panel, and we will start the MySQL and here, and we will open it on the browser, and you will see the PHP my admin which is in the browser you can see, and we will create the database here and then the table here. The database creation is quite simple and it is not difficult. The difficult part, I think, is to how to connect the database and the website and the Wi-Fi module and the Arduino. And next, we have to create the PHP code file to make the database out. We have to access the connection between the database and the Arduino module. Just like the code I have shown on the right hand side, there is some name or password need, and finally the database will show. Also, we will put the data into the web page just like this. This is a simple version of the web page just for testing, and phone will make it more user friendly afterward. And the ESP8266 mentioned before is used to connect the Arduino and the web page through internet, and the PHP code will help find those data on the website and put it into the database in your local host. And also the Arduino IDE programming. We need to access the ESP8266 Wi-Fi module. We need to make it work. We need to program it and set some serial number to access it, and we will connect it with IP address through internet. And the usage of our server is mainly used for save data. While the database has been created, we can use other apps or device just like iPhone or maybe other computer program to connect with the database, and the customer can monitor the data and take it out. Expect live monitoring. Customer can check the data a few days ago because the database will not be deleted until the storage is full, just the data in the database. Yeah. And the deadline is the deadline made by the customer is that today, and the data will be deleted. And in the further discussion, we hopefully could upgrade the system into bigger server with multi-monitor, large amount of sensor unit. With this, we need to upgrade the sensor unit to detect more different kind of air particle, and also upgrade the LCD to display uh, more different kind of particle. And finally, if we can, we want to upgrade the design of the web page and make it more user friendly. And this is the end of our presentation. Thank you.